The story of the Bugatti Chiron being driven again after a massive crash is something that feels almost unreal. For months, people in the car world believed that this car would never move again. Bugatti is known for making some of the most advanced and expensive cars in the world, and when one of their cars is badly damaged, it is usually considered finished. In this case, the Chiron was not just damaged, it was split into two parts. Many experts believe that rebuilding such a car without official factory support was impossible. But that is exactly what Mat Armstrong and his team set out to prove wrong. This project was not just about fixing a car, it was about challenging a belief. It showed that with enough skill, patience, and creativity, even the most complex machines can be brought back to life. The moment Mat finally sat behind the wheel and drove the Chiron for the first time after the rebuild was both exciting and terrifying. Every small sound, every movement of the car carried risk. Would it hold together? Would something fail? These questions made the first drive one of the most intense moments in the entire journey. This story is not only about cars, but also about determination, problem solving, and the courage to take on something that others say cannot be done. One of the biggest challenges in this rebuild was the cooling system, especially the radiators. These parts are extremely important because they control the engine temperature, and without proper cooling, the engine can quickly overheat and get damaged. Since original Bugatti parts were not available, Bob had to create custom radiators from scratch. This alone was a huge task that required skill, precision, and time. After many hours of work, the radiators were finally ready and shipped to Mat. But then something unexpected happened. During shipping, the radiator got damaged because part of it was sticking out of the box. The box was dropped, and the impact caused a leak. This was a frustrating moment because it meant starting over again. Bob had to remove all the custom parts he had built, find a new radiator core, and rebuild everything once more. Even after doing all that, another problem appeared. The new radiator was just 1 millimeter different in size compared to the old one. It may sound like a very small difference, but in a machine as precise as the Chiron, even 1 millimeter can cause serious issues. The mounting points no longer lined up, and everything had to be adjusted again. This shows how difficult the process was, where even the smallest detail could create a major problem. And yes, the work continued. More challenges appeared, especially when it came to fitting and sealing the radiators. After adjusting the size and installing them again, leaks were found in the system. These leaks were caused by tiny holes in the welds, which are very hard to notice but can cause serious problems. The team had to drain all 39 liters of coolant from the system, remove the radiators again, and fix the issues. At one point, Mat even tried to weld the leaks himself. He had watched Bob do welding many times and felt confident enough to give it a try. However, this attempt did not go well. The welds were not strong enough, and the leaks remained. This moment was important because it showed that some skills take years to master, and it is not easy to replace experience. In the end, it was clear that Bob's expertise was needed again. This part of the journey highlights the importance of teamwork and knowing your limits. While Mat was determined to learn and help, he also understood when it was better to step back and let a professional handle the job. These setbacks made the final success even more meaningful, as every small victory came after multiple failures and lessons. Another surprising part of the rebuild was discovering that many components in the Chiron were not unique to Bugatti. Instead, they were shared with other cars from the Volkswagen Group. For example, parts like the fuse box, air pump, and even some crash sensors were found in cars such as the Lamborghini Gallardo, Audi A3, and other Volkswagen models. This was unexpected because the Chiron is a multi-million-dollar hypercar, and many people assume that every part in such a car is specially made. Finding these shared components made the rebuild slightly easier, as replacements could be sourced without relying on Bugatti. It also changed how people think about luxury cars. While the Chiron is still an incredible machine, this discovery shows that even the most expensive cars can use parts from other vehicles. This does not reduce its value, but instead highlights how large car companies share technology across different brands. For Mat and his team, this was a big advantage, as it allowed them to continue to rebuild without waiting for rare or unavailable parts. It also proved that with enough research and effort, solutions could be found even in the most difficult situations. One of the most impressive achievements in this project was the creation of the front crash bar. This is a very important part of the car because it holds many other components in place, including the bumper, sensors, and bonnet lock. The original crash bar was completely destroyed in the accident, and replacing it was not easy. Normally, such a part would be made using detailed designs or advanced scanning technology. However, no one was willing to provide a Chiron for scanning, which meant the team had to find another way. Bob took the damaged crash bar and used it as a reference to build a new one from scratch. This process took more than 60 hours of careful work. He had to cut, shape, weld, and adjust the metal to match the original design as closely as possible. The level of precision required was extremely high because even a small mistake could affect how other parts fit. When the new crash bar was finally installed, it fit perfectly on the first try. This moment was a clear example of skill and craftsmanship. It showed that with enough experience and dedication, even the most complex parts can be recreated without advanced tools or factory support. After solving the major structural and cooling problems, it was finally time to test the car. The cooling system was filled with 39 liters of coolant using a vacuum filling method, which helps remove air and ensures proper flow. This process was slow and required careful monitoring to make sure there were no leaks. Once the system was filled, the engine was started and the temperature began to rise. This was a critical moment because any issue in the cooling system could cause the engine to overheat. The team watched closely as the temperature increased, waiting to see if everything would work as expected. When the cooling fans turned on and the temperature stabilized, it was a huge relief. It meant that the radiators were working correctly and the engine was safe. This success was not just about fixing a problem, but also about proving that the custom-built parts could perform just as well as the originals. It was a major step forward and gave the team confidence to move on to the next stage of the project. Finally, the moment everyone had been waiting for arrived, the first drive. The car was not fully complete, as it still lacked some parts like the windscreen, but it was ready to move under its own power. Matt sat in the driver's seat, knowing that this was the result of months of hard work. As the engine started and the car began to move, there was a mix of excitement and fear. Driving a car that was once split in half is not something anyone would take lightly. Every sound and movement was carefully observed. As the car accelerated, it felt smooth and stable, which was both surprising and reassuring. Some warning lights even turned off, showing that the systems were working correctly. Despite the success, Matt described the experience as scary, which is understandable given the situation. This drive was not just a test, but a proof that the impossible had been achieved. It marked a turning point in the project and showed that the car was truly back to life in the end. This rebuild is more than just a story about fixing a damaged car. It is a story about determination, creativity, and the willingness to challenge limits. The fact that a Bugatti Chiron could be rebuilt and driven again without factory support is a powerful message. It shows that even the most complex problems can be solved with the right mindset and skills. Mat Armstrong and his team proved that what was once considered impossible is actually achievable. Their journey was full of setbacks, mistakes, and learning moments, but they never gave up. This is what makes a story inspiring, not just for car enthusiasts, but for anyone facing a difficult challenge. It reminds us that failure is part of the process, and that success often comes after many attempts. In the end, the Chiron driving again is not just a technical achievement. It is a symbol of what can happen when people refuse to accept limits and keep pushing forward no matter how hard the journey becomes. This rebuild of the Bugatti Chiron didn't just prove that a crashed supercar can be brought back to life. It also raised a bigger question about how modern hypercars are designed and whether they are truly as untouchable as people believe. Most people think cars like this are built in secret factories with completely unique parts that cannot be replaced or copied. But this project showed something very different. Many systems inside the Chiron are actually based on shared engineering from a much larger automotive group. That does not make the car less special, but it does show that even the most advanced machines are still built using real-world engineering principles that can be understood, repaired, and recreated. The biggest lesson from this build is that complexity does not always mean impossibility. When something is broken down step by step, even a machine worth millions of dollars can be studied and rebuilt using patience and logic. The team did not rely on official manuals or factory support. Instead, They used observation, problem-solving, and trial and error. Every small win added up over time, until the car that was once considered beyond repair started to function again. This changes the way people look at supercars because it shows that they are not magical objects, but extremely advanced machines built by humans. And anything built by humans can, in theory, be repaired by humans if enough effort is put in. One of the most important parts of this entire project was not just the tools or the parts, but the skill and experience of the people working on it. Bob played a huge role in making the rebuild possible. His ability to fabricate parts like radiators and crash structures from scratch was what kept the project alive. Without his knowledge of welding, metal shaping, and mechanical understanding, the rebuild would have stopped very early. What made his work special was not just accuracy, but adaptability. When something failed, he did not stop. He changed the design, adjusted measurements, and tried again. This mindset is what allowed complex problems like the radiator leaks or crash bar reconstruction to be solved. At the same time, Mat's role showed a different kind of value. Even though he was not always successful when trying technical tasks like TIG welding, his willingness to try and learn added to the process. He was not afraid to fail in front of the camera, and that honesty made the journey more relatable to viewers. In real engineering projects, success rarely comes from one person alone. It comes from teamwork, communication, and shared problem-solving. This rebuild showed that perfectly. One person had fabrication expertise, another had mechanical experience, and together they created solutions that neither could have achieved alone. It is a strong reminder that skill is important, but collaboration is what turns difficult projects into successful ones. The reason the story gained so much attention is not just because of the car itself, but because of what it represents. The Bugatti Chiron is not just a vehicle. It is a symbol of extreme engineering, luxury, and exclusivity. When people hear that a car like this has been split in half and rebuilt outside a factory, it immediately creates curiosity. Most viewers are used to seeing supercars treated as untouchable machines that only specialists in official workshops can repair. So when someone outside that system successfully rebuilds one, it challenges that belief. It also adds drama because there is constant uncertainty throughout the process. At any moment, something could fail, and the entire project could fall apart. This creates a natural storytelling structure that keeps viewers engaged from beginning to end. Another reason it works so well is the mix of technical detail and emotional reaction. On one side, you have complex engineering problems like radiator sizing, cooling systems, and crash structure fabrication. On the other side, you have human reactions like stress, excitement, frustration, and relief. This combination makes the story both educational and entertaining. It is not just about watching a car get fixed. It is about watching people deal with real problems under pressure. That is why this type of content performs so strongly online. It blends real engineering with real human emotion in a way that feels authentic. The first drive of the rebuilt Bugatti Chiron was more than just a mechanical test. It was a result of months of effort, problem-solving, and repeated failure. When the car finally moved under its own power, it represented the moment where theory became reality. Everything that had been designed, welded, adjusted, and tested was now being pushed to its limits on the road. There was no more guessing at this point. Either the car would work or it would fail in real time. That is what made the moment so intense. As Mat drove the car, even small details became important. The sound of the engine, the stability of the steering, and the behavior of the cooling system all mattered. When the car continued to run smoothly, it was a clear sign that the rebuild had succeeded. But even in success, there was still tension, because no one could fully predict what might happen next. That mix of achievement and uncertainty is what makes engineering projects like this so powerful to watch. It shows that success is not a single moment, but the result of many small decisions made correctly over time. In the end, the drive was not just about proving that the car could move again. It was about proving that persistence, skill, and determination can turn something broken into something functional again, even when the odds seem impossible. The rebuild of the Bugatti Chiron also opens up a deeper discussion about how modern supercars are actually built. Most people imagine that a car at this level is made from completely unique, custom-designed parts that exist nowhere else in the world. While that is partly true for some components like the engine and chassis design, this project revealed a more practical reality. Many systems inside the car are influenced by shared engineering across a large automotive group. This means that even extremely expensive and exclusive cars can still use parts or systems that are related to other vehicles. This discovery does not make the Chiron less impressive. In fact, it shows how advanced modern car manufacturing has become. Companies often share platforms, electronics, and mechanical systems to improve reliability and reduce development time. What makes a hypercar special is not just whether every single part is unique, but how all those systems are combined into one high-performance machine. The Chiron still represents one of the highest levels of automotive engineering in the world. However, this rebuild proves that even the most advanced machines are still based on engineering logic that can be understood and reproduced. It challenges the idea that these cars are completely untouchable. Instead, it shows that with enough knowledge, patience, and hands-on experience, even highly complex systems can be repaired outside of official environments. This is an important lesson not only for car enthusiasts, but also for anyone interested in engineering and problem-solving in general. While most of the attention in this story goes to the technical achievements, there's also a strong emotional side that should not be ignored. Working on a damaged Bugatti Chiron is not just about tools and parts. It is about pressure, uncertainty, and constant problem-solving. Every stage of the rebuild brought new challenges that tested patience and confidence. There were moments when things failed repeatedly, such as leaking radiators or misaligned components, and each failure required starting again. These moments can be frustrating, especially when dealing with something so expensive and complex. However, they also create a sense of progress over time. Each solved problem becomes a small victory that pushes the project forward. For Matt, there were also moments of self-doubt, especially when attempting tasks like welding without enough experience. These moments added realism to the journey because they showed that even enthusiastic people cannot instantly master complex skills. On the other hand, Bob's calm and experienced approach provided balance during stressful situations. His ability to stay focused under pressure helped keep the project moving forward even when things went wrong. This emotional mix of frustration, learning, teamwork,